We can also do curve fitting in Excel. So here I have an Excel file that has the same set of data points as the X and Y vectors that I created in MATLAB. And in lecture, you're going to talk about how you can export data from MATLAB into Excel and how you can pull data from Excel into MATLAB. But if I want to do curve fitting in Excel, I simply have to select the data that I want to curve fit. So here I've selected my column of X and Y values. I go to the Insert tab in Excel, and then for charts, this little icon right here is a scatter chart. So if I choose scatter plot and click on that, I have several options for what I want that scatter plot to look like, but I'm going to pick the first one. Alright, and if I do that, then I get a plot that looks very similar to what we were looking at in MATLAB. To do the curve fitting, I can right click on a data point and go to Add Trend Line. And I will get a little menu here that opens up about what I can do with my trend line. And let me make this a little bit smaller so you can all see. The first thing that it does is it automatically chooses a straight line for that trend line. But if I would like to go to a polynomial, I can scroll down and choose polynomial, and it'll do a polynomial fit for me. If I want to see the equation for that polynomial, if I scroll down, I can choose Display Equation on Chart and display the R-squared value on the chart. Now let me slide that over again so that you can actually see. And what you should notice here, if you look at that equation, y equals 2.9759x squared minus 6.5919x plus 5.1136, that is exactly the same polynomial equation that we got with MATLAB. Both Excel and MATLAB use the same type of algorithm for determining what the best fit curve to data is. So whether you're using Excel or MATLAB for polynomial fits, you should get exactly the same values. Now, one thing that's different though is this R-squared value. R-squared, that coefficient is computed completely different than what the norm of the residuals is, and we're going to look at that equation in just a moment. But let me tell you right at this point that if we had a perfect fit, the R-squared value would be 1. This is different from the norm of the residuals. Remember, in MATLAB, with the norm of the residuals, we want that value to be 0. That means all the y values fit with the original data points. In Excel, we would like the R-squared value to be as close to 1 as possible, 1 being an absolute perfect fit. So here's the equation for the R-squared value. It looks like a pretty complicated equation, but what it's really doing is measuring how well the original y values match with the fitted y values. The R-squared value will always be a number from 0 to 1. If R squared is equal to 1, think of that as a 100% perfect match between the original y values and the fitted y values. 0, on the other hand, represents a very lousy match between the original data values and the fitted curve values. As mentioned, it's possible to take Excel data, import it into MATLAB, take MATLAB data, and export it out to Excel. We're going to demonstrate this in lecture, but just let me mention a couple of things before you get to lecture. There is a command in MATLAB called XLSRead that allows you to take data from an Excel file and read it right into MATLAB. MATLAB also has a nice import tool that can be used to pull data from Excel into MATLAB, and both of these things will be demonstrated in lecture, along with some more curve fitting. You can also export data from MATLAB to an Excel sheet. This can be done two different ways. First, MATLAB has a function called XLSWrite, which will write MATLAB data into an Excel file. And it's also possible to simply copy the data from the variable editor window and paste it into an Excel file. And both of these things will be demonstrated during lecture.